Every night, the starry sky treats us to a complimentary spectacle of light. And within it, there are celestial events that can astonish even those who are not easily impressed. Greetings, everyone. For those who desire to witness a cosmic fireworks display, I encourage you to grab some popcorn and turn up the volume. Let's embark on a journey together as we gaze upon the night sky. Yes, ladies and gentlemen, welcome to our channel. Today, I'd like to discuss what would happen if a supernova explosion occurred near Earth. Can we indeed survive such an event? And what fate awaits us, the inhabitants of Earth? Are you intrigued? Well then, let's get started. A supernova, the grand finale of a massive star's life cycle. Stars are born quietly. However, the death of a star is accompanied by a fantastical scene, spreading a breathtaking spectacle for neighboring planets. To see another light in the dark sky, one must wait for millions of years. It all begins with the accumulation of sufficient amounts of dust and gas in space. Particles attract each other, rotate, form spheres, and eventually become the core of a star. And thus, through the work of hydrogen, gravity, and time, a new beacon of the universe is born. Under tremendous gravity, gases are heated to immense temperatures, releasing vast amounts of energy. Nuclear reactions begin in the core, lasting for millions, billions of years. This may seem like an endless process, but stars too eventually meet their end. This is due to the depletion of fuel. Unfortunately, as the universe's gas stations have yet to be invented, stars cannot simply purchase more hydrogen. Thus begins the irreversible process of stellar death. The first to perish are the high-mass stars. According to scientists, the Sun has passed halfway through its 10 billion-year lifespan. The life of a very massive celestial body is akin to that of a rock star. The larger and brighter the star, the quicker its demise. Celestial bodies with 20 times the mass of the Sun are extremely short-lived, some reaching their end in 10 billion years, others in 5 billion years. The agony of death for any large star begins with a shortage of hydrogen. Next, helium is compressed and the core becomes hot. New chemical reactions begin, turning helium into carbon, carbon into neon, neon into oxygen, and oxygen into silicon. This laboratory work continues for thousands of years. This process reaches its climax as silicon turns into nickel, and nickel collapses to become iron. Inside the star, the heart of a few kilometer-wide iron ball is pulsating. When the core becomes unstable and collapses, a large number of elusive particles called neutrinos are emitted from the core. The star sheds its upper layers, scattering them throughout the universe. We see light and scientists detect neutrinos and radiation. A supernova explosion shines brighter than the light of stars in an entire galaxy. The most famous supernovae witnessed by humanity. In the vastness of space, about 10 stars explode every second. However, such shows are visible to Earthlings only about once every 100 years. The oldest record of a significant celestial event was left by Chinese scholars. In 1006, a massive flash appeared in the constellation of Lupus. This is now known as the supernova SN 1006. According to ancient astronomers' records, the light was so bright that it cast shadows even during the day. In April 1054, Chinese scholars recorded another new shining light in the sky. It was visible for several months. The explosion occurred at a distance of 6,500 light-years from Earth. Such a powerful explosion led to the formation of the Crab Nebula after the death of the giant star. Its bright glow indeed resembles a crab. To cross this celestial crab in the sky, one needs to traverse a distance of 11 light-years. It's not difficult to imagine the scale of this ancient fireworks display. Additionally, in 1572, Danish astronomer Tycho Brahe observed the appearance of a bright light spot. this light was visible even during the daytime. This event occurred at a distance of 7,500 light-years from Earth in the direction of the constellation of Cassiopeia. He described the celestial body he discovered as closely resembling Venus when it approaches Earth. Even at noon, a bright spot was visible in the sky. Perhaps the most famous supernova was recorded by Johannes Kepler. The appearance of a bright light in the European sky was confirmed on October 9, 1604. Although the explosion itself occurred 20,000 light-years away from Earth, the light from the star's death could be seen for a year. Over 400 years have passed since this event occurred. Doesn't it feel like quite some time has passed since another light lit up the sky? What would happen if a star exploded near Earth? There are no astronomers who can accurately predict when and which stars will explode next. Based on observations and survey data of celestial bodies, such an event could happen at any time. But when catastrophic phenomena occur, what exactly awaits the inhabitants of Earth? So far, nothing particularly terrifying has occurred. That's because Earth has overcome multiple supernova explosions without suffering significant consequences. Or has it? The cases of stellar explosions recorded in history represent only a small fraction of what Earth and its inhabitants have witnessed. While some explosions have been truly harmless, others have shaken the cosmos extensively upon the death of individual giant stars. What poses a high risk to Earth, as you may well understand, are supermassive stars that are close to Earth. All celestial bodies are constantly in motion. We are currently hurtling through space at a speed of 30,000 kilometers per second. For example, some stars, like the Alpha Centauri triple star system, approach and move away from Earth. One of these celestial bodies approaches within 1 light-year of Earth every 500,000 years. This is now considered a close distance. If at that moment the star decides to leave a powerful impact on us, the force of its particle stream may blow away Earth's atmosphere. Without oxygen, life cannot exist. However, the risk of a supernova explosion does not end there. During the process of a star exploding, its radiation could cause further irreparable damage to Earth's atmosphere. The reason we are alive and able to do things, whether we like them or not, is thanks to the ozone layer in Earth's atmosphere. Ozone protects us from cosmic radiation. However, if a very large star were to explode near Earth, we might as well start writing farewell letters because we wouldn't live much longer. When a star explodes, gamma rays are emitted, destroying ozone molecules in Earth's atmosphere. In other words, nitrogen atoms bond with oxygen atoms, breaking down ozone molecules. Earth loses its shield and its inhabitants suffer, unaware of whose wrath they have incurred until they perish in agony. Where do such pessimistic statements come from? They come from Australopithecus. No, they didn't leave us a letter of lament. Scientists discovered that about 2.5 million years ago, Earth suffered from the power of a dying star. Iron-60 elements were found in sedimentary rocks at the bottom of the Pacific Ocean. This radioactive isotope is only produced by the explosion of a star. Many scientists speculate that a supernova caused a mass extinction at the end of the Pleistocene. During this period, about a third of large animals perished. Radiation is suspected as the cause of extinction. Cosmic radiation collided with particles in Earth's atmosphere, forming muons, muon particles. These heavy charged particles were so numerous and fast that they affected large animals. However, compared to even more powerful cosmic tragedies, a supernova explosion may just be an unpleasant event. That tragedy is called a gamma-ray burst. It is caused by a hypernova, an extremely powerful supernova. This occurs when two neutron stars merge or when a celestial body 30 times the mass of the Sun explodes. In the funeral of such stars, two gamma-ray beams are emitted in parallel. Even if these cosmic beams are emitted more than 6,000 light-years away from Earth, if their radiation reaches Earth, the habitable area of the solar system will turn into a wilderness. However, there is still no evidence indicating that Earth is threatened by a gamma-ray burst. What kind of stars are potentially dangerous for Earth? Current technology is insufficient to thoroughly explore the vast expanse of space. However, within the cosmic panorama that scientists observe, there are several celestial bodies lurking that could potentially threaten Earth. For instance, the red supergiant Betelgeuse in the constellation of Orion is a star on the brink of becoming a supernova, causing concern among astrophysicists for years. This star could explode at any time. Of course, considering the vast time frames on a cosmic scale, there's no need to worry beforehand. Vega, illuminating the night sky in the constellation of Lyra. It's a massive star that rotates rapidly. Scientists speculate about the instability within this star, and that instability could lead to the star's collapse. Similarly, the red supergiant Antares in the constellation of Scorpius is also not to be trusted. Currently, this star is actively burning fuel. Its demise is inevitable, but no one knows the exact date of its future explosion. So, that's it for today's video. Thank you all for watching. When one of these stars puts on its final show, Earthlings might enjoy it from the front row. Of course, that's if they're still alive by then, because this significant event won't happen for millions of years. Anyway, there's no need to worry about it now. We've made it this far, and with the knowledge and technological level of the future, we should have a better chance of surviving such upheavals than our ancestors did. Let's part on such a positive note. Thank you for joining us to enjoy the cosmic fireworks. Until next time, goodbye everyone.